In this example, we want to determine the right-hand limit, the limit as x approaches 1 from the right of the function 3 times the square root of x minus 1. So here our function is 3 times the square root of x minus 1, and a is equal to 1. We are going to use the table of values approach here, but we're only going to do one of the tables. We're going to do the table as x approaches 1, but from the right-hand side. So values a little bit bigger than the number 1. So let's begin by using the a value 1.1. We're going to substitute that into the function and evaluate that using our calculator. Converting this into a decimal number, we get about 0.9486. I'm going to go back and I'm going to alter this so that we have 1.01 inside of our function, and then go ahead and evaluate once more. We get 0.3. So based on these two decimal numbers, it's hard to make a definitive statement about the limit, so we're going to keep going with an extra 0. Doing this next evaluation gives us about 0.0948. Again, it's still a little bit unclear because our numbers seem to be bouncing back and forth. So let's go back and update this to get in an extra 0. Doing this evaluation gives us 0.03. And now maybe you can start to see the pattern emerging. So when I go back and add an extra 0 in here, I'm going to get something close to 0.00948. And then finally adding in that last 0, and converting this to a decimal number, we're going to get about 0.003. So while not obvious at the beginning, it is a little clearer now that this limit is going to tend towards 0, because we're bouncing back and forth between values like 0.9, and then 0.3, then 0.09, then 0.03, 0.009, and 0.003. So we're adding more and more zeros in front of the 9s and 3s, so we can conclude that the limit as x approaches 1 from the right of 3 times the square root of x minus 1 does appear like it's going towards 0, based on our table of values.